There we are. Yeah. Of course. Okay, so if we could all come to order, this won't take long. I just want to chat about one little thing. Yes, order in the court. One little thing left to talk about electron configurations, and then one more thing to plant a seed for the next unit. And we've learned so far about electron configurations of atoms, and it's been very easy to determine how many electrons an atom has, because if it's an atom and not an ion, the number of electrons is the same as the number of what? Protons, exactly. And how do you know the number of protons on for an atom? It's the atomic number. So you look at bromine, you're like, okay, bromine's atomic number 35. So if we're talking about just straight bromine, then there's 35 protons and 35 electrons. Easy peasy. Well, we can also write electron configurations for ions. Okay? If you remember ions from 2 months ago, an ion is an atom that has more or less electrons than protons. So before we go any further, let's just review. What is the charge of an electron? Negative. So if you add an electron, the ion becomes negative. And if you take away an electron, the ion becomes positive. Good. You add negatives, negative ion, add positives, or remove negatives, and it becomes a positive ion. Good. So again, we can write electron configurations for ions just like we write electron configurations for atoms. So take a look at sulfur. There's your answer to sulfur. Oh, so that's what sulfur is. Yep, that's sulfur. And sulfur ends 3p4, which means there's 2 holes in the 3p orbitals. And we could replace those 2 holes with electrons. What do you think it would look like if sulfur gained 2 electrons? 3p6, exactly. Yeah, so if sulfur gained 2 electrons and it had a charge of -2, the configuration would be neon 3s2 3p6. Easy, right? Okay. So sulfur can be the sulfur atom at 3p4, sulfur -1 at 3p5, or sulfur -2 at 3p6. Can sulfur be 3p7? Can anything be 3p7? No. Because the p can only hold 6 electrons, exactly. And we're not going to add electrons to the point where we add orbitals. Okay? We can fill up partially filled orbitals, but we're not going to add electrons to the point where we create new orbitals. So there isn't going to be an S3 minus where it's 3p6, 4s1. Not going to do that. Okay? Does this idea make sense? Yeah. Okay, 90 seconds, zoom, right by. Okay. And you can go the other way too. So here's calcium. Calcium's configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So calcium is hanging out over in the s block, level 4, 2 over, and it can lose electrons. What if calcium lost 2 electrons? Which 2 electrons do you think it's going to lose? No, 4s, yeah. And this is what calcium 2+ would look like. These have special names, by the way. A negative ion is called an anion, and a positive ion is called a cation. Mentioned that before, but I'm going to mention it again because it's going to be really important in the next 2 units. The next unit is about periodic trends, and then the next unit after that is the big one about bonding, how electrons are used in bonding. Okay, so does this idea make sense? You can add electrons to an atom to create a negative ion by filling up empty orbitals. You can also take away electrons and wipe out orbitals. In this case, the entire 4s2 was wiped out. And you created calcium 2+. And what do you notice about these 2 ions? Yeah, they have the same electron configuration. Sulfur 2- and calcium 2+ both have the same electron configurations for reasons that will become apparent very soon. But before I show you that, let's talk about titanium. Titanium, everyone's favorite metal. Titanium has the electron configuration argon 4s2 3d2. Believe me, or am I off? Can you confirm that? You're just like, you're the boss, Mr. Byers, you're probably right. You could put 3d11, I'd buy it. You're the teacher. I'm just here. I'm just here to play Clash of Clans. So you're the teacher. Okay. So titanium is argon 4s2 3d2. And here's what's goofy about D block metals. When they form ions, they do not remove those electrons in filling order. When titanium forms a 2+ ion, it has the configuration argon 3d2. The 4s has been removed. They don't fill in reverse, they don't get removed in reverse filling order. The 4s actually gets removed instead of the 3d. One of the reasons why almost all D block metals have a +2 ion. It's going to be important when you take chemistry AP. You have to decide, in chemistry AP, you actually have to memorize the common ions of things. Ugh. But anyway. But yeah, titanium 2+ is argon 3d2. The 4s2 has been removed. Anyone have any idea why that might be?
Because 3d is the placement of
If you...
What do you do with the fact that the D thing only already starts at 3 instead of 1?
No. But it's, if you're going to take an electron away from an atom, where are the electrons?
the outside.
On the outside. So you're going to find your 4s electrons, even though they're higher in energy, are further from the nucleus. So if you were to draw your Ds, and they look something like this, with the loop here, and the loop here, and the loop here, and the loop here. So if this is your 3D orbitals, all zooming around, your 4s is probably something like this. 4s. So your 4s is a sphere outside or further away from the nucleus. So those are the electrons, even though they are lower in energy, those are the electrons that are going to be removed first. Make sense? Okay, last thing. I'm going to have to back up a little bit to a previous slide. All right, so I showed you the noble gases, neon, argon, and krypton. Helium's up, technically a noble gas, but not for the purposes of our discussion today. What do you notice that is common about all noble gases?
They all end with 6.
Yes, they all end P6. All noble gases end P6, which is really handy because in the modern periodic table, the way we've arranged our periodic table, the end of the periodic table ends with the noble gases. P6. So neon ends 2p6, argon ends 3p6, chromium ends 4p6. Now there's these things called valence electrons. And valence electrons are the number of electrons in the highest energy level. When you look at the entire configuration, the highest energy level will give you the valence electrons. In neon, what's the highest energy level? 2. And how many electrons are in that level?
2.
Not 2, not 6, but
3.
8, yeah. Because there's 2 there and 2 there, there's 8 electrons in the second level. So in neon, neon has 8 valence electrons because there are 8 electrons in the highest energy level. Make sense? And now you know the pattern. What's the highest energy level for argon? 3. And how many electrons are in that level? 8. 2 there, 2 there, for a grand total of 8. And krypton's 4th level is the highest level. How many electrons are in krypton's highest level? 8. 2 there, 6 there, for 8. Yeah. So each of the noble gases have 8 electrons in their highest energy level. This has a special name. It's called an octet. 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 Like an octopus or an octagon. Okay. Pikachu. I wonder if you can figure out why Pikachu's on this presentation. Good guess, but no. It could have been a Bulbasaur or a Squirtle, but it could have been any old Pokemon. It could have also been like a Ken Griffey Jr. baseball card. Or it could have been one of those crazy spoons or shot glasses.
What? Why?
What are other things? So baseball cards, Pokemon cards, shot glasses, spoons. What are other things that you collect?
Coins.
Coins, yeah. Could have been all those things.
Rubber bands.
Rubber bands?
Like rubber band balls. Tape.
Fair enough.
I have a tape ball.
So when you go to Germany, you're like, I need to see your tape. I'm making a tape ball.
Yeah.
Fair enough. All right, so an octet is 6 and 2 electrons in the highest energy level. It's a total of 8 electrons in the highest energy level. And it is those valence electrons that give the atom all of its bonding properties, which is what we're talking about in the next 2 units. By the way, valence is kind of a neat word. If you have curtains that have a little mini curtain on top, that's called a valence. Or if you have those plastic or wood blinds that has one big wood slab across, or a plastic slab across the top, hiding the hardware, that's also called a valence. So, maybe. Although they are spelled differently. Maybe. Maybe val and valence are similar. But yeah, so valence are things that are outward or above. So the valence electrons are the highest energy ones. And an octet happens when you have 8 valence electrons. An atom's ultimate goal in the atom life is to have an octet. The ultimate goal of any atom is to have an octet. They spend their entire life attempting to get one and then keep it. The reason noble gases are mostly unreactive is if you ask neon, hey neon, you want to exchange electrons and make a bond? Neon's like, no, I'm good. I got my octet. Don't need it. I don't need any more. Don't want to give them up. Don't need any more. Okay, argon. Hey argon, I noticed you got 8 electrons. You want one more? No, I'm good. I got my octet. Can I have one? No. Can't break my octet. It's kind of like Pokemon cards. If you had 191 of 192, you're going to try really hard to get that last one, right? I don't know what you guys collect. Clash of Clans heroes? I don't know. So yeah, you're going to try really hard to get that last one. And that's how atoms work. If they have almost an octet, they try really hard to complete their octet. Let's look at an example. Actually, there's an example right here. Chlorine. If you can't see chlorine, I'm going to write it down. Chlorine has the configuration neon 3s2 3p5. I'm sorry?
6.
No, I forgot the L. Right. Thank you. No, chlorine ion is 3p6. Chlorine is 3s2 3p5. So how many valence electrons does the chlorine atom have? What do you mean you need your glasses? Instantly improved vision. That's got to be at the top of your list. Like, I'm going to school, but I'm not going to see anything today. Okay, so chlorine has 7 valence electrons, whereas the chlorine ion, as written up there, the chlorine ion is 3s2 3p6. The chlorine ion has 8 valence electrons. Which one do you think is more stable?
Chlorine ion.
The chlorine ion. All atoms want to obtain somehow their octet. So chlorine does it by getting an electron. Potassium does it by losing one. Potassium ends 4s1. If potassium loses that single 4s1 electron, it attains 8 valence electrons. Hey potassium, how many valence electrons you got? I got 1 in the 4th shell. It's not doing me any good. Can I have it? Here you go. Hey, now I have 8 in my next shell. That's an octet. I'm a happy ion. That's basically how potassium works. If you were to interview a potassium, that's what it would say. So that's how it works. And this is going to be the basis for all the trends we're going to be playing with next unit and how we bond the next unit after that. Questions?
Nope.
Can we turn it back off? No, we can't.